Astronomers have witnessed 5 massive explosions on the planet Jupiter as fragments from the Shoemaker Levy collided with the planet. Larger explosions are expected later this week.
They called it the biggest explosion in the solar system for hundreds of years. Half an hour after the first comet fragment went in, the impact was still visible. The cloud of debris spread out for thousands of miles and was over 1,000 miles high. The astronomers were jubilant.
We're going to see things and we're going to learn a lot. That's the good news tonight.
The clear divide between the inner and outer solar system is the legacy of a ring structure that existed a very long time ago in the planet-forming disk that surrounded the Sun, according to researchers. Some astronomers believe that one reason Earth is habitable is that the gravity of Jupiter does help protect us from some comets, long-period comets in particular, enter the solar system from its outer reaches. Jupiter's gravity is thought to sling most of these fast-moving ice balls out of the solar system before they can get close to Earth. So, long-period comets are thought to strike Earth only on very long timescales of millions or tens of millions of years. Without Jupiter nearby, long-period comets would collide with our planet much more frequently. The closer we look at the universe and the objects that are close enough for us to observe, the more we are realizing that the forces at work are an accumulation of past events. Resettling with gravitational forces around the larger mass, and in this sense, it doesn't matter how massive or small an object is, because the inevitability is that it all happens anyway. Dust gathers and rings form. We see this most dramatically at Saturn, but we do have documented asteroids and other objects like the Earth that also have this debris forming around about it. Now, for the first time, researchers in Tokyo and Colorado have compiled evidence from the formation of disks that surround young stars and have combined this data with the formation of the planet Jupiter, and the results, they say, prove that the formation of the solar system wasn't as hectic as first thought. In fact, this giant disk that surrounds the Sun may have fundamentally altered the structure of the solar system, preventing today's terrestrial planets from acquiring more matter to become giants. They also believe that other high-pressure rings are likely to exist further out in the solar system, and the gas giants may have formed as they fell into the lower pressure sinks that lay between the rings. The solar system is clearly divided between the inner rocky planets and asteroids, and the outer gas giants, with the border between the two regions lying between Jupiter and the asteroid belt. This difference can be quantified in terms of carbon, with the element being much more abundant in the outer part of the solar system than it is in the inner rocky planets and asteroids. The difference is so stark that astronomers now widely believe that material in the newly formed Sun's planet-forming circumstellar disk was similarly divided in terms of its composition. For some reason, carbon-rich material from the outer solar system has been prevented from migrating into the inner solar system. One explanation for this barrier is that it arose during the formation of Jupiter. As the gas giant gathered mass, the theory proposes it prevented carbon-rich dust and sub-meter pebbles from reaching the inner solar system. Jupiter is the greater protector of the inner planets. Comet Shoemaker-Levy 9 was captured by her gravity, torn apart, and then crashed into the giant planet in July 1994, and witnessed by the citizens of the Earth for the first time. When the comet was discovered in 1993, it already had been torn into more than 20 pieces, traveling around the planet in a 2-year orbit. Further observations revealed the comet, believed to be a single body at the time, had made a close approach to Jupiter in July 1992 and was torn apart by tidal forces resulting from planet's powerful gravity. The comet was thought to have been orbiting Jupiter for about a decade before its demise. The disruption of a comet into multiple fragments was rare, and observing a captured comet in orbit about Jupiter was even more unusual. But the biggest and rarest revelation was that the fragments were going to smash into Jupiter. World governments took a particular interest in this American mission, with NASA turning the Galileo mission into a position to watch the event. For the first time in history, a collision between two bodies in the solar system unfolded. The impact started on 16 July 1994 and ended on 22 July 1994, with many Earth-based observatories and orbiting spacecraft, including Hubble Space Telescope and Voyager 2, also studying the impact and its aftermath. The freight train of fragments smashed into Jupiter with a force of 300 million atomic bombs. The fragments created huge plumes that were 2,000 miles high and heated the atmosphere to temperatures as hot as 30,000 to 40,000 degrees Celsius, 53,000 to 71,000 degrees Fahrenheit. Shoemaker-Levy 9 left dark, ring scars that were eventually erased by Jupiter's winds. Scientists have calculated that the comet was originally about 1.2 miles wide. If a similar sized object were to hit Earth, it would be devastating. The impact might send dust and debris into the sky, creating a haze that would cool the atmosphere and absorb sunlight, enveloping the entire planet in darkness. If the haze lasted long enough, plant life would die, along with the people and animals that depend on it to survive. If Shoemaker-Levy 9 had missed Jupiter and hit Earth back in the 90s, we wouldn't be here. The current research being carried out regarding the rings suggests that similar rings were likely to have existed around the Sun as the planets were forming. If so, they could have created regions of high-pressure gas and dust, which would have been difficult, though not impossible, for carbon-rich objects to cross. If these ring structures lasted long enough, the researchers do argue that they could have fundamentally altered the structure of the solar system, preventing today's terrestrial planets from acquiring more matter to become giants. Ultimately, their work suggests a need for a fundamental rethink of Jupiter's role in the solar system's characteristic distribution of carbon. With the diversity of observations of circumstellar disks gathered by ALMA, they could also help astronomers to learn more about the formation of star systems other than our own, and you can read the research in the journal Nature Astronomy, which we will link below for your viewing pleasure. What do you guys think about Jupiter? Is it stopping certain materials and objects from coming into the vicinity of the inner solar system? Or has the past century just been very lucky for Earthlings? Some say that in the years 1770 through 1779, the planet Jupiter tried to kill us. In fact, it is as if Jupiter took aim at the Earth with a comet and just missed. Comet Lexell, named after the Swedish astronomer who discovered it, whizzed only 1 million miles from the Earth in 1770, missing us by a cosmic whisker. The comet had come streaking in from the outer solar system 3 years earlier, and passed close to Jupiter, which diverted it into a new orbit and straight toward Earth. The comet made 2 passes around the Sun, and in 1779 again passed very close to Jupiter, which then threw it back out of the solar system. Hal Levinson, an astronomer at the Southwest Research Institute, who studies the evolution of the solar system, said that whether Jupiter was menace or protector depended on where the comets came from. Lexell, like Shoemaker-Levy 9 and probably the truck that just hit Jupiter, most likely came from an icy zone of debris known as the Kuiper Belt, which lies just outside the orbit of Neptune, he explained. Jupiter probably does increase our exposure to those comets, but Jupiter helps protect us from an even more dangerous band of comets, coming from the so-called Oort cloud, a vast spherical deep freeze surrounding the solar system as far as a light year from the Sun. Every once in a while, in response to gravitational nudges from a passing star or gas cloud, a comet is unleashed from storage and comes crashing inward. Jupiter's benign influence here comes in 2 forms. The cloud was initially populated in the early days of the solar system by the gravity of Uranus and Neptune sweeping up debris and flinging it outward. But Jupiter and Saturn are so strong that, first of all, they threw a lot of the junk out of the solar system altogether, lessening the size of this comet arsenal. Second, Jupiter deflects some of the comets that get dislodged and fall back in. Also guys, just before we go, the astronomer who operates the virtual telescope, Gianluca Masi, has confirmed the exciting discovery of an asteroid that entirely exists within the orbit of Venus. Gianluca reports that the asteroid was first spotted by a team at the Polymer Transient Factory on January 4th of this year, followed by a team at the Minor Planet Center, which had temporarily named it ZTF09K5, publicly posted the finding. Intrigued by the finding, Gianluca Masi set himself the task of confirming the find because its preliminary orbit indicated it never moved out of Venus's path. After waiting for clear skies, he scheduled time on a telescope in Italy and was able to program a remote-controlled unit on the telescope called ELNA, which allowed him to use the telescope over the internet for 30 minutes. He noted that the process of photographing the asteroid was difficult because it was low in the sky, and the sky was not very dark, and there was a full moon. Despite the difficulty, Masi reports that he was able to capture multiple images of the asteroid, which he combined to account for the object's motion. Once he had a finished photograph in hand, he sent it to the Minor Planet Center. Several hours later, his confirmation was posted on the Minor Planet Center Circular with its new name, 2020 AV2. Masi and the team at Minor Planet Center also confirmed that 2020 AV2's orbit was completely inside Venus's orbit, the only known such asteroid. He notes that it also has the smallest known aphelion distance in the solar system other than Mercury. You have to consider the purpose of such an orbit, and of course further study is needed of these objects in question, which could be remnants of ancient activity out in space millions or billions of years ago. But what do you guys think about this? Comments below, and as always, thank you for watching.